Hi, good morning, everyone. Uh, Today, we are very fortunate with us to have with us Dr. Robert Nemiroff, who is the co-founder of APOD, the very prestigious NASA science website, as our guest, and he will be talking about NASA's best space image is for 2023. Uh, And later on, our ALP member, Miss Imelda Johnson, will make the introductions for Robert. And for those who were not able to log in or register, you can actually watch this also live streaming at uh, at our uh, Philippine Astronomy Forum Facebook page. It's currently live streaming now if you were not able to register. And some webinar rules, of course, to make this an enjoyable experience for everyone. Uh, Please pay your divided attention to our speaker and enjoy the talk. And we will be also having a Q&A later on for this webinar after the talk. And of course, all of the images here that will be presented is the sole property of the presenter. And this will be the outline of today's webinar. Let me turn you over now to the President of the Astronomical League of the Philippines, Mr. James Kevin T., to give his welcome remarks.
Good morning to our viewers in the Philippines, and good evening to our guests in the United States and Europe. My name is James Kevin T., President of the Astronomical League of the Philippines. On behalf of the ALP, I would like to welcome you all to our Astronomy Experts Speaker Series 2023. This webinar is part of ALP's International Astronomy Educational Outreach Program. Our goal is to bring renowned experts and scientists to the Filipino people and to the rest of the world. That is why the webinar is being offered free to the general public. I would like to also take this opportunity to thank ALP members who have been instrumental in putting up this program all together, especially Imelda Johnson, Edwin Aguirre, Dr. Jet Aguilar, Jun Lau, Kendrick Cole KCT, Andrew Ian Chan, Peter Benedict Bernal, Eric Africa, and Justin Chen. So this will be the 21st lecture in our speaker series. Our speaker for today is no other than Dr. Robert Nemiroff, co-founder of NASA Astronomy Picture of the Day. We have more distinguished speakers lined up for the coming months. So please stay tuned and please do not forget to register in advance for this future webinar. Thank you very much. And now, I would like to turn over the program to Imelda Johnson, who will be introducing our speaker for today.
Thank you, James, and thanks to all our viewers tonight and basically today in the Philippines. Well, tonight's topic is very close to my heart, and it brings back happy memories of my time as photo editor of Sky and Telescope magazine. Photos are very powerful in capturing our attention and imagination. It inspires and educates us and awakens our curiosity. That is why through the years, I've always enjoyed looking at the astronomy picture of the day. And less than a decade ago, had the honor of meeting the man behind it at one of the meetings of the American Astronomical Society. And tonight, we'll get a chance to spend some time with Dr. Robert J. Nemiroff. Robert received his Ph.D. in astronomy and astrophysics from the University of Pennsylvania and his main research interests include gamma-ray burst, gravitational lensing, and cosmology. In 1995, Robert co-created the Astronomy Picture of the Day, popularly known as APOD, which he continues to co-write and co-edit to this day. He is a fellow of the American Physical Society and a recipient of the 1997 National Science Foundation Career Award. He worked at NASA's Goddard Space Flight Center in Greenbelt, Maryland, before joining the physics department of the Michigan Technological University. In 2012, Robert received the Michigan Technological University Research Award, and in 2021, the University Professor Award. In 2023, the International Astronomical Union named asteroid 2002 GB185 as 270558 Nemiroff in his honor. This year, he published a popular science book entitled Faster Than Light: How Your Shadow Can Do It, But You Can't, which is available through Amazon. Friends, let us welcome the man behind the beautiful pictures of APOD, Dr. Robert J. Nemiroff.
Thank you very much. Okay, I'll now try to share my screen, which has my presentation. So it will be a momentary, which one is it? There it is. Okay. So now I'm going to start my slideshow. So there. So you should be able to see the first slide, which says Year in Review 2023, Astronomy Picture of the Day. So I am, hopefully you see my cursor, Robert J. Nemiroff, and this was APOD, as we call it, is created and written by two people still, me and Jerry T. Bonnell. So I am at Michigan Technological University. Jerry is still at NASA Goddard, but also at University of Maryland. And I am very happy to speak here to the Astronomical League of the Philippines. So thank you very, very much for inviting me. Okay, so what is the Astronomy Picture of the Day, sometimes called APOD? Well, you can get there pretty easily just going to apod.nasa.gov, and you will get that day's image. And so we started this in 1995, and it has become one of NASA's most popular science websites. And we typically do more than 1 million page views a day. We're also on almost every social media platform. Our log files have shown us that typically every major university in the US will access APOD every day, and were translated by volunteers into about 20 world languages. So please follow us. Every image that you will see today is or will soon be available on the apod.nasa.gov website. So if you wanted to see something, if you wanted to know more, you can just follow. We don't give a link, but we give you the day and you can find it from our archive. Okay, so I'd like to go a little bit into the past, although we're going to be doing the best images of this year, over the past year, and show a couple of images that we've run over the years from the Philippines. So this one is of a beautiful, and we've run this a couple times. So we run best ofs on weekends. This is a partial eclipse over Manila Bay, and it's just beautiful. You can see the moon here on the left and the sun behind it, and you can see Manila Bay, and you can see some structures before it, and it is just a beautiful picture of the eclipse. This eclipse that happened in 2009. This was an annular eclipse in some places, but from the Philippines it was a partial eclipse, and it was very well captured. So another one, this was by Christopher Go, who was mentioned in the introduction, and from Cebu City, and this is a triple transit of Jupiter. So here you can actually see all 4 of the largest satellites of Jupiter. Jupiter obviously is the big thing here, and you can see Io over here, and you can see the other 3 moons. And this is particularly interesting because you can see not only that sometimes a moon will create a shadow onto another moon, but you can see the black spots or the shadow of these moons from the sun onto the surface, the cloud tops of Jupiter itself. And you can see the sequence as the as Jupiter rotates and as the moons orbit Jupiter. So this is a particularly spectacular shot, and it was featured on the Astronomy Picture of the Day on August 21st, 2021. And if you go there, you can see a lot of details. Okay, so let's go into the past year, but I'm going to go back a year in December and go back to the beginning of December. And so NASA itself, here you can see the two NASA logos. This one's called the meatball and this one's called the worm. And we are currently running the Artemis series, and the Artemis series is a return to the moon. But now, unlike in 1969 and in the 60s when NASA went to the moon, now there's company because many countries and some private companies like SpaceX have the moon in their sights and have landed on the moon even recently. But here is a Artemis 1, which flew in late November 2022 and early December 2022. And here it did a wide loop around the moon for returning to the Earth. And here you can see the moon here and the Earth here looking like a twin pair of planets. Well, actually, the Earth is much bigger than the moon, but still, the moon is relatively large for a moon going around a planet. So the Earth-Moon system is a little bit unusual in that Earth has one moon, and that moon is pretty large, roughly the size of Jupiter's moons, the four largest of Jupiter's moons that we saw going around Jupiter earlier. So the Artemis series will continue, and in the next few years, there are sometimes delays, they're hard to predict. We'll be landing people back on the moon in the next couple of years. So here's one of the images that we love showing on the Astronomy Picture today. So this is a multiple series of images all stacked up together, but all of these images are related because they're all taken from the same location with the same camera pretty much consecutively, although the background images were taken much deeper. And so with this kind of image, you get just a lot. First, you can see the astrophotographer. This is taken from Lofoten, Norway, northern Norway, and you can see the photographer lighting up some of the foreground, the very rocky foreground. You can see aurora in the Earth's atmosphere. You can see a meteor in the Earth's atmosphere. So these weren't, the aurora were much dimmer, the meteor was much dimmer, so it was brought up with post-product effects. And so here you can see the band of our Milky Way galaxy. So you can also see the Big Dipper, the bright Big Dipper stars, which are made a little bit brighter, so you can see them more easily. You can see the planet Jupiter, and you can see the Andromeda galaxy, which is a fuzzy spot right there. Several bright stars, including Vega. So astrophotographers now go out of their way to create some of these amazing landscape, skyscape combinations. And if your eye could see deep enough, you could actually see all of these at the same time. But you can really see these because with a camera, you can integrate over much longer periods of time. And you can take an image of the foreground and with the same camera, then take a longer image of the background and put them together with programs like Photoshop to create what the eye might see if the eye could see deep enough. And so these are just spectacular images showing what is possible in the night sky. Okay, so last year, around this time, there was the Geminids meteor shower, and I will bookend this at the end by showing an image from this year's Geminids meteor shower. So this is what's called the Mittens in the US, Utah. And so you can see streaks from the meteor shower, and you can see Geminids, Castor and Pollux are the two bright stars that are the twins, and it looks like the meteors are streaming out of the Geminids constellation. But actually, we are going through a trail of dust-sized particles that are orbiting the sun, all along with the parent comet or asteroid that shed these small bodies that then fall to Earth. Okay, so, oh yeah, so we try to run all kinds of interesting images, and this is actually an illustration that we ran on the Astronomy Picture today, and this was a rerun in January 2023. So this shows the periodic table of elements, and it shows where these elements come from. So all the elements in your body have an astronomical origin. For instance, your body is made of mostly water. I happen to know that because all humans have bodies made of mostly water, and the hydrogen in that water came from the Big Bang. So part of you was created in the Big Bang, 13.8 about billion years ago. There's also other elements that you're made of. Most people are made of carbon. Not a coincidence. And you can see from this that carbon comes from dying low mass stars mostly, and also exploding massive stars. So we know where most of these elements have come from. However, we don't know them all. Astronomy is really a frontier. Science is a frontier. We're always learning more and more. It's not like a book that you read from and say, okay, here's the answer to this, here's the answer to that. We're always learning more. So there are some elements, for instance, copper, that we're really not sure exactly where it came from. How much of it is due to exploding white dwarf stars and how much is due to exploding more massive stars. So that is a topic of research, and one of many topics of research that are big in astronomy today. All right. So we're now in an era where we're learning a lot about planets outside of our solar system. There's still an unknown. There still could be distant planets in our solar system, but we know of 8, used to be 9, one was demoted, but there could be even more further out. But with telescopes like Hubble and some ground-based telescopes and the James Webb Space Telescope, we're able to see the existence of planets around other stars, and those are called exoplanets. So we can't see images like we're seeing here. All you can see is the image. We can see the starlight from some distant star, and we can see that starlight become slightly dimmer and then brighter again. And the dimmer and brighter is created by a planet moving in front of that star. But we can determine the brightness to such accuracy now that we can say there must have been a planet going around that star, and then we can think about what is that planet like. So this planet around LHS 475b is probably very rocky from what we know of its size and likely mass, and probably very hot. And the star we know is a red star, a small red star. And so we can then ask, what might this star look like? Now, there are astronomical artists that create images, but one thing that we did this time is we actually asked artificial intelligence, in this case, deep AI, we fed in, here's the attributes of this system. Tell us what it would look like from the surface of this planet. And it gave us something that was completely not right because it had plants and stuff. And so we said, no, do it again. Again, it was wrong, so do it again. Eventually, we refined the search enough, and we found something that looked pretty cool, and we think relatively realistic. But we don't really know this. This is an artificial intelligent reconstruction. So one of the cool things about this artificial intelligence revolution that humanity is now embracing in some way and is afraid of in another way is that it can help us in many ways. It can help us visualize things in astronomy that we couldn't as accurately visualize before. And so it's doing that with the surfaces of exoplanets that are discovered. However, we then found out here at the Astronomy Picture of the Day that this particular AI engine was trained with some images that might have had copyright restrictions that were not appreciated by the artificial intelligence programmers at the time. So we actually had to take this image down because it might have had some copyright violations that we were not aware of at the time. So, but that doesn't mean they will always be down, and the modern AI engines that are coming up are trained with sets that have less copyright possibility violations. So the artificial intelligence revolution that we're slowly undergoing is changing and is affecting not only how amateurs process images, because a lot of image processing now in astronomy has some very sophisticated programming behind it, some of which could be called artificial intelligence, but in other aspects too. So it's the AI revolution is affecting amateur astronomy and professional astronomy both. So this is just one case where it actually intersected the astronomy picture of the day. Okay, so we've had a couple of bright comets over the past year, but not super bright. This is comet ZTF, which is named after the program that discovered the Zwicky Transient Facility. And so this comet was not as bright as it appears in this image. You could see it barely with your unaided eye, but with long duration camera images, you can make it really, really pop. And so here we see both of these in the image that we wrote are falling. The comet is falling toward the sun as it does its highly elliptic orbit around the sun. And Yosemite Falls in US has water falling toward the Earth. And they were, this image was sent in to us and they were both falling at the same time. So again, the background image and the foreground image is not a single shot, but it was taken by the same camera at the same location consecutively. So the background shot is much deeper. And it's just a really cool shot that we were happy to feature. Okay, moving on to the next one. We're approaching an unusually active period for our sun. Now, our sun is usually very calm and has been very calm for the past, billions of years, relatively calm, or it's unlikely that life on Earth could have grown up the way it has. So we're happy to have a very inactive sun, but that doesn't mean completely inactive. We're so close to our sun that we can see surface magnetic activity that shows that it undergoes a 22-year cycle, which because the polarity flips, it's sort of 11-year cycle, and we're unusually active now. In the minimal period a few years ago, there were like months would go by without almost any activity that we could see on the sun at all. It was a very calm sun. But now we're getting very high activity, and you can see there's filaments, and there's filaments seen on the edge, and you can see active regions. And so even though our sun is relatively close and is the best studied star by far, it still gives us surprises. And we don't know how active the sun will become over the next year or so before it hits solar maximum in 2025. Now, this is more than of passing interest of people who image the sun, because the sun will throw off flares and coronal mass ejections, and those flares can affect satellites orbiting the Earth, and they can even affect power grids on the Earth. And so it's important that it can affect astronauts who are in orbit around the Earth. So it's important in many ways for humanity to understand how our sun acts and be able to predict the future activity of our sun. And we're always learning more and more about that. By the way, in comparison, this is the side of the Earth up here. Okay, so let's go. Over the past year, there was a very interesting conjunction on the sky, angular conjunction between Venus and Jupiter. And so here you can see 10 days. One of the days the moon was close. You can see the brighter one is Venus, the dimmer one is Jupiter. They're two of the brightest objects you can see on the night sky. Here they are coming together, and it was quite remarkable. If you were going out there, I think at sunrise, you would see these two objects moving closer and closer together, and they were really quite remarkable. So this was in March of this past year. Here is an image that was sent in to us over Germany. One of the great things about these things is that this Jupiter-Venus conjunction convergence wasn't just visible from Germany or from the US, it was visible from pretty much the entire world, which is one of the themes of the International Astronomical Union and one of the themes of the Astronomy Picture of the day, is that everybody sees the same sky. Everyone is going to see the same phases of the moon. Everyone is going to see things like Jupiter and Venus converge. Everyone's going to see the same lunar eclipses. Solar eclipses, not so much. That's another story. But here we can see a family outside, someone looking through a telescope, other people pointing to the convergence of Jupiter and Venus. And you don't need a fancy telescope for this. For many astronomical events, like lunar eclipses and planetary convergences, you just need to know to be able to go outside, either at sunrise or sunset, and look up in the direction of just where the sun was going to rise soon, or the sun has just set, and see something fairly remarkable. Also, meteor showers are something that you can see. So we'll return to that. But if you miss it, you can find images all over the web. In particular, you can find images of some events, most astronomy events, in fact, on the Astronomy Picture of the day. And for this one, if you wanted to see this picture in more detail, you'd go to the March 15, 2023 one. Okay, we live in a golden age where there are spacecraft, unmanned spacecraft that are going past or orbiting around many of the planets in our solar system. And so this one is the Juno spacecraft that's orbiting Jupiter right now. It's in an orbital, a long elliptical orbit. And here is one of the times when it swooped over the surface of Jupiter and got a really great view of many clouds. Typically, the lighter colors are higher up and the darker colors are deeper down. And here you can see a lot of the swirls of the complex clouds of Jupiter. Our Earth would easily fit into this large white oval. And so we're learning a lot about Jupiter from Juno. We're trying to figure out whether Jupiter's magnetic field is simple, and we're learning that it's not simple, and we're trying to figure out whether Jupiter's core, among other things, is solid, and we think it's generally not so solid, or it's somewhat complex. But Juno is taking a lot of data and also taking a lot of cool images from around Jupiter, and it continues. Okay, so the sky is filled with legends, and almost every society has its own legends. So one of the unfortunate things that I've come to appreciate over the past few years is that the constellations that we refer to are really constellations that have come out of ancient Greece or though acknowledged by the Western world. But almost every local culture has its own legends of the night sky. Since everybody sees the same night sky, everybody sees the same constellations, patterns of stars, asterisms of stars, and they give them different meanings. So in the US and in Western culture, we generally don't create this to be anything, this galactic plane, this is the plane of our galaxy, to be anything to have any lore, but that's not true for people in Uruguay. They say this is the Nandu. I don't know if I'm pronouncing that right. I've seen it many times, but one thing about writing APOD is that I see a lot of the written words, but I don't hear them. So I typically will mispronounce something, sometimes humorously so, and so I apologize for that. But this is a big bird. And now when I see this part of the Milky Way, I can just say, oh yeah, that reminds me of the big bird. And these legends are passed on through generations and are really a way of generations bonding with each other. Oops, I didn't mean to do that. Bonding with each other. So this is a statue of a famous woman from Uruguay who was famous in fighting against colonialization, which is another theme. But for many generations, the Nandu of the Milky Way. And so there's many cultures, every culture, I think, has sky legends, and we should preserve those as best we can and promote them. Okay, so this is a map of the universe. So one of the things about modern astronomy and astrophysics is we can see further out in the universe than we can ever before with big telescopes. And so this is also true of the James Webb Space Telescope, but this is true of a survey telescope called the SDSS, the Sloan Digital Sky Survey. So this is a wide-angle telescope that just tiled the entire sky and saw lots of galaxies, which are shown at the bottom of this plot. This is a wedge of the sky. This is an angular part of the sky. And so you can see that as you go further out, more distant parts are higher up here. The microwave background is here. So as you go further out, you can see galaxies appear more red in this specific way, which here means redshift. So one of the things we know is that as you go further out, galaxies have a higher and higher redshift, which means that the cosmology of our universe takes every wavelength band that it emits and moves them down to the more red colors. And so here you can see the galaxies appear more red, and then when we run out of red, suddenly it becomes blue again. So what's happening with this? What happened to redshift? Well, what happens is you're not easily able to see the galaxies anymore, but you can see the centers of galaxies. And they are known typically as active galactic nuclei if they're bright. And so here the center of galaxies are seen much further out at redshifts of 2 and 5, and they're more blue. But as you go further out, even those turn more red as the redshift of the universe has an effect on those too. Also, you can see that as you go to closer and closer times to the present epoch, because you were here at the bottom, the gravity of the universe pulls galaxies together and makes them into more filaments. And that's more evidence at the bottom than it is at the top. At the top, they're much more uniform. Okay, so this was released in 2023. So humans first landed on the moon in 1969, but with modern digital techniques, including artificial intelligence, we can now reprocess some of those images and see them in new ways. This was a famous part of a picture that that Buzz Aldrin, one of the first two people on the moon with Neil Armstrong, landed on the moon in 1969, took a picture of Neil Armstrong, and you can see Neil Armstrong's visor. But with modern AI techniques, you can now reverse engineer this and show what it is reflected from this visor. So this is a reflection, I think, off of Buzz Aldrin's visor, and you can see Neil Armstrong, first person to step on the moon, through the reconstruction of this, and you can see the lunar module here, and you can see the shadow of Buzz Aldrin. So this is a selfie taken in 1969, arguably the first lunar selfie. Okay, this is an image from the latest, greatest space telescope called the James Webb Space Telescope, but this is actually a merger of both Hubble and Webb images. So the Hubble Space Telescope has been flying since the 90s, and the James Webb Space Telescope just went up in about a year or so ago, a couple years ago, and so it's taking really detailed images. Webb is really good at going into it's a much bigger image, much bigger mirror than Hubble. Hubble is about 2.4 meters across mirror. The James Webb Space Telescope has a 6.4 meter mirror and looks into the infrared light much better. Webb actually goes into orange light, so it can see the red part of optical light, but really excels at infrared light. So here we can see the Ring Nebula, which you can see with your average backyard telescope from a dark location in greater detail than ever before. And you can see a star in the center. This is what might happen with our sun. It will throw off its outer layers into a planetary nebula. And even before that, will undergo some unusual events. But this won't happen for our sun for about 5 billion years. But we can see from other stars what will eventually happen with our sun, so far as we can tell. Okay, there was another comet that came just to the edge of naked eye visibility with your unaided eye, and this is comet Nishimori. And so this was visible in August and September of 2023. It wasn't seen before this, and here you can see the ion tail and the green coma of the comet. So every year or so, there are always comets on the sky. If you have a deep enough telescope, you can pick up comets. But they become really spectacular when they become bright enough to see with the unaided eye. So in this past year, we had 2 of those, and this was the latest one, but we didn't have any that really grew much brighter. We never really know how bright comets will become. So this comet could have been much brighter, and when we showed these images on APOD, we didn't know how bright it would get, but we were happy that it reached visibility with the unaided eye. So here you can see a detailed ion tail. And here you can see this was captured in the pre-dawn sky, and you can see very bright Venus, and you can see a long exposure of comet Nishimura with a nice long ion tail. So you can get an appreciation for how that was. Let me see if I can find what, trying to find, sorry, lost my, okay. I know I won't be able to find it. I have in my notes, which I don't see right now where this was taken. All right, let's go to the next one. So James Webb continues to sparkle and shows us a star that's forming with a star that's emitting jets. So you can see the jets in the infrared, which are here shown in red. And you can see it's a Herbig-Haro object that throws off jets. Here you can see the star is embedded in this dust cloud. So one question is, do all stars create jets as they're forming? And modern astronomy isn't sure. But when they do form jets, and many of them do, they sure look spectacular. So James Webb Space Telescope is taking images of the early universe, and we're telling us about the early universe. It's taking images of exoplanets and telling us about other planets around other stars that we didn't know about. But it's also taking images of planets in our own solar system and planets that are forming in nearby stars. And so here's one of those. So OSIRIS-REx visited asteroid Bennu in the past couple of years, and then it collected a handful of material from Bennu, and it ejected a pod, which then fell back to Earth with satellites. So here it is in the vast Utah desert, and landed, and you can see it's black it got much heated, even though it had parachutes. And so currently, it hit the ground in September of 2023, just a few months ago, and the sample was recovered and is now being studied in labs around the world, and trying to find out what it is about Bennu. Did asteroid Bennu have carbon material that could have indicated that it seeded Earth or other places with enough carbon for life? Did it have some heavy elements in it that could mean that asteroids like Bennu, which actually comes pretty near the Earth, has some interesting elements that might be mined and hence brought back to Earth, or things like that. So we're learning about satellites asteroids that come near the Earth by analyzing little bits of it that are caught and ejected and land on Earth. Okay, so this past year, in October 6, 2023, it was the 100th anniversary of the day that Edwin Hubble essentially realized for the first time, for sure, that our galaxy, the Milky Way galaxy, was actually a galaxy and one of many, many galaxies in the universe. So here we see the Andromeda galaxy, and in there he found right here a star in there, and this star he realized on October 6, 1923, was a variable star. It wasn't just, these little fluffy nebula are not just nebula that are also in our Milky Way galaxy or just nearby the Earth. This nebula is actually made of stars, and these stars are made of variable stars. And these Cepheid variables, we can estimate how bright they are. And since they're that bright and they appear that dim, but they're actually very bright, they must be very far away. And therefore, this Andromeda galaxy is not just the Andromeda Nebula, it's the Andromeda galaxy. And it must be very far away. And all those spiral nebulae we see on the sky, like you can see behind me, those are separate galaxies. And so we live in a vast universe, and we've only known this for 100 years. Before that, there was a big debate as to whether these spiral nebulae were just part of the one galaxy, one universe that we thought. But we now know the universe is much more vast. But there are people alive today who were alive when humanity wasn't sure of that. So astronomy as a science is, still maturing and has undergone revolutions even in the past 100 years. Okay, so it was the eclipse that went across the US. There was an annular eclipse. And so one of the cool ways to see an annular eclipse is not necessarily looking up at the annular eclipse, but looking down on the ground. And when you look at the ground, and sometimes if you look at a tree, then light from the annular eclipse streams through little breaks in the tree and creates lots of images of the eclipse that's occurring in the other direction. And so here you can see lots of images of the annular eclipse, those occur in the other direction. And you don't need any special glasses to see this. So you can see many images of an annular eclipse just by looking in the opposite direction of a tree, or actually you can take your hand and go like this, and the sunlight will steam through your fingers, and you can create little images of the eclipse on the ground. So this is a popular thing to do. In the other direction, you can actually see the eclipse. So this was sent to us after the eclipse, and so we featured this, I think the day after. So this was visible in Oregon, US state, and here you can see the moon in front of the sun. You can see the sun all around the moon, which makes it an annular eclipse. But here it's called eclipse rings, because although these two people were part of three that were undergoing great planning as to being in the right place at the right time to take a really cool image of them being silhouetted against an eclipse, but the fellow knew something the woman didn't know, and that is that during this imaging session, this picture session, that he would ask her a question that she did not fully anticipate. And it involved another ring. And so the answer to this was yes. And so this is a very popular, it's a really cool image. Actually was a little skeptical when I heard this story, so I did some background checking and everything checked out. So this is a really cool image that we ran just after this annular eclipse passed over part of the USA. So Juno keeps orbiting Jupiter, and just in October, it made a close pass through one of the most interesting moons in the solar system, which is Io. Io is a moon that has lots of volcanoes, and it's turning its inside out. It just keeps regurgitating what's inside the moon, and that keeps coming out on the outside of the moon. So a lot of these are volcanic craters, but just when Juno was passing by, not a big coincidence, that you can see at the just above, it's hard to see here, that Io was actually producing another visible volcanic eruption. Now, there's at the end of this month in December, Juno will also be making another even closer approach to Io, and then during the next year in February of 2024, we're doing another very close approach, and we'll be able to get new images of this very, very interesting moon of Jupiter, which is actually very close in size to our own moon. So there was the Lucy spacecraft, which is moving out toward the asteroid belt and taking images of asteroids. So this is one it passed along the way. It's called Dinkinesh. And what we didn't know is that Dinkinesh was actually a binary asteroid. It had a little moonlet that orbits this bigger one. And actually, you can't tell here, but there's another one as well. So these two orbit each other, and they all orbit this. This is about 100 kilometers across. And so Dinkinesh is going out to Jupiter to pass through and image many other. Lucy is going to be going out to Jupiter and imaging many other asteroids to find out what the early solar system was like and when it combined the early part of the solar system condensed into asteroids at Jupiter. Okay, so this is an image of a dust devil on Mars. So there's two rovers currently rolling around Mars. So one is Perseverance, one is Curiosity. So here Perseverance was watching, this is the surface of Mars, and here you can see the dust devil, and I'm going to play a movie, and you can see the dust devil move across. Ready, go. This takes about 20 minutes. So we have dust devils here on Earth. That was so exciting. I'm going to run it again. Here it goes. This was a series of maybe 10, 15 images, and it was banded together by, you guessed it, artificial intelligence. You fed in the images, you asked for it to make a smooth movie, and although the programming capability was possible before that, it's now available to a much wider audience through artificial intelligence. Okay, going to the next image. Oops. So in this past year, a new space telescope was launched. The Euclid Space Telescope was launched by the European Space Agency. NASA actually has one of the imagers on that, but this Euclid can see some very wide images and is there to take images of the entire sky, and with it will hopefully determine more about dark energy and dark matter which pervade our universe. So it's part of what Euclid will discover in its continuing mission. But it does have some pretty cool imaging capability. So there's not just Hubble and Webb in orbit. There's also Euclid, and we're going to be hearing more from Euclid a lot in the near future, I'm sure. Over in 2021, but as reported in this past year, a large particle hit the Earth from deep space. We don't know how large the particle is, but it had TeV energies. And so these particles create cosmic ray air showers. Now, almost any massive particle, fast particle, which is probably either a proton or the nucleus of iron or something, or carbon that hit the Earth, they create an air shower. So here at the top of the Earth's atmosphere, it hits, and then it creates a spray of particles, protons, electrons, muons, that hit the Earth, and they hit all over the Earth. But this one just happened to hit a a array in Utah. Utah's getting a lot of play. There's lots of US states, but Utah has an array and saw a lot of the spray, some of the spray from this particle. And when reconstructed, this was a very energetic particle, one of the most energetic particles yet seen. And so this raises questions. What gave this particle that kind of energy? So also, when you try to trace this particle back in the sky, you can say, okay, where did it come from? Even if we don't know what created the energy, maybe if we just go back, if it came from this direction, we can say, well, what was there? There's nothing that appears to be there. So this is another strange mystery that we don't understand currently. This is another really cool, just like saying. This is a cool image that was taken of the Carina Nebula with the Hubble Space Telescope. And so here you can see it's just spectacular imagery that Hubble is still returning. So there are stars here that are being born here and that are evaporating these torch-like cocoons by emitting energetic light and emitting energetic particles that evaporate the cocoons that are condensing into these stars to begin with. And I jumped ahead. So this will be one of my last images. So this is, oddly enough, the astronomy picture today from December 17, 2023, which it is currently in the Philippines, but it's not where I'm speaking in the USA. So this has not yet appeared on the astronomy picture today. This is tomorrow's astronomy picture of the day. I happen to know it. And this is Geminids from the Gemini meteor shower, which was visible in the past week, and some of which are still coming in. You might be able to see. This is an image taken over China. And it's a conglomerate image, so a lot of the streaks, hundreds of streaks are visible here. And you can see two people appreciating this meteor shower that is coming from appears to come from the constellation of Gemini. I will leave you with a sunset, the sun setting over Hawaii, and you can see what's called a mythical thing, but it's actually true, called the green flash. And so the green flash is actually an atmospheric phenomenon. You can see many green flashes over the next 60 seconds as this sun melts into the sea. And you can see, if you watch the top, you can see many green flashes. So I'll run this. You might be able to hear the sound of the ocean, but if not, you can hear me. And the Earth's atmosphere creates leveling effects where you can see different atmospheric optical effects. So the sun melts into the horizon. I'll just let it melt in. It's cool to watch. The different layers in Earth's atmosphere. There you can see a green flash go up. This is in real time. This isn't time lapse. This is what it looks like. You have a telescope watching a sunset over the ocean. And here it goes, the final green flash, which actually for a moment turns blue. Oops. So with that, I'll thank the Astronomical League of the Philippines again. Some postscripts. So APOD did receive the inaugural outreach prize of the International Astronomical Union in 2022. APOD's been running for 28 years. And so June 2023 was our 28th anniversary. So Jerry Bennell and I, have been doing this for a while. And so we've got a bit of experience. So we're grateful for NASA for continuing us. And here's a self-plug that this new book called Fast in the Light, which is available through Amazon. And so, here's that. Just like our presenters, Edwin and Imelda, and also I also now have been very fortunate enough, and Jerry and I have an asteroid renamed after me. So with that, I'll open this up to questions, and I'm again grateful to have this opportunity to present this to you. And I will stop presenting now. Thank you.
Wow, thank you so much, Robert. It was an inspiring and really very educational experience for us. And we really appreciate now not only the beauty, but the science behind all of these APOD images. I would like to share my slide now again. So we have some Q&A questions in the Q&A box, but can I just maybe I'd like to start with a question. I think we have a lot of amateur astrophotographers or astro imagers in the audience, and how do they submit their images to APOD, and what are the what are the screening or the criteria for image submissions?
Okay, good question. I do have my Q&A window open, but I'm not seeing any questions. I'm not sure why. It seems
Yeah,
empty.
I some of them were messaged to me, but
Okay,
actually this
all
is
right.
my own
I'm happy
questions.
to answer the question. So good question. So we get a lot of image submissions. So we accept submissions from all over the world. Unfortunately, well, fortunately for the world, but unfortunately for individual astrophotographers, we reject about 20 images for every one we can accept. We just get so many good images submitted to us. So why would an image be accepted? So we're looking for things that would appear. So if you had a group of amateur and professional astronomers that were sitting around, and they all had a bunch of images, and they could vote on what image characterized astronomy for that day, what is it that was most talked about? That is the one we are probably most likely to pick as the astronomy picture of the day, because it sort of is the astronomy picture of the day, but we have to guess what that is. Another way to think about that is that for astronomy textbooks, if we're sent an image and we think, oh, this is sure to be in an astronomy textbook, then we're very likely to include that as a future astronomy picture of the day. And sometimes we miss them and we have to go back and a few days later and include that. Other things are, if it's a very topical image, if there's a meteor shower like the one running tomorrow, if there's an eclipse and it's like over Manila Bay, then that's being a topical is a very positive thing, because people want to talk about what they see. We want to also broadcast what's coming up. So topicality, educational content, if there's an image that really shows something very educational, like for instance, the periodic table, and shows where your elements came from. So that's just something that's like mind-blowing in a way. And we just decided that we just want to go with that because people can learn so much from that familiar icon. So these are some of the criteria. We're also sometimes surprised. Many times we will post images to a Facebook page called apod.sky, and we'll see which ones are popular. Popularity is not the only criteria we use, though. Some people think, well, if it's popular, it's guaranteed, and that's not true. However, if we do realize that an image is popular out there, that does increase the chances that we will feature it on the astronomy picture of the day. So those are just some thoughts I have on that. Hope that's a help.
Thank you, Robert. I have some questions that were given to me via messaging.
Sure.
There's nothing yet there in the Q&A chat box, but I think in relation to the images that are submitted to APOD, the question is how many gigabytes or terabytes of images has APOD accumulated over the years? And related to this is, how do you archive all of these images?
Okay, good question. So the amount of images, we only run an image a day. So that's 365.25 or so images a year. That's not all that many images. You're probably archiving more than that on your smartphone right now. So one surprising thing about archive is that about APOD is that our entire archive is not really all that large. And so it's completely held on a couple of disk drives at NASA Goddard Space Flight Center, but could easily be backed up on, with a drive you could buy online. The videos are the biggest ones now. So sometimes a video can take up a much bigger amount. So in terms of static images, we're less than a terabyte. In terms of videos, yeah, we're about a terabyte or so, which is a hard drive you can buy. So storing the images is not our biggest problem. Also, when we present an image, we realize that people who are accessing our images don't have that great a bandwidth. And so we try to reduce the amount of file size, at least on the main image, so that it comes over relatively easily to even people who don't have high bandwidth connections. So if you're going to see the main image on APOD, you don't have to have a high bandwidth connection to do that. So the collection of all of the images that have appeared on the front page of APOD doesn't take up all that much because they're relatively low, so that we can make it so that people can see this over relatively low bandwidth connections. Yeah, I think that is a good question, and maybe people think that we need a tremendous amount of disk space, but that's not our biggest problem. Is trying to select from how many great images are submitted, and housing all the great images that are submitted is a little bit more troublesome than the ones that are shown. But it's still a good question, and thanks for asking. So I have a cat here who's
Thank you.
here's
Thank you.
going on,
Yeah.
and she wants to participate, but so that's fine. So a cool question.
Thank you, Robert. We're all so grateful for APOD and really appreciate all the work that you're doing for APOD. And the question is, where do you get funding to support the program? And hope we can continue with the APOD program.
Or our
Where
funding
do you get
comes
funding?
from. Okay, so our main source of funding right now is NASA. So we're part of something called Science Activation. So NASA has a science activation program that we're only one of 30 or so programs that is funded. So we're grateful for that. But APOD being 28 years old actually predates NASA's science activation program. So we got money from NASA's Goddard Space Flight Center before that, and we've gotten money from our home institutions. For instance, Michigan Tech has provided some money in the past. But early on, we go to the very early years of APOD, we weren't getting any compensation for this. We were just doing it because we just thought this was cool, and we just thought, we wanted to be part of the web, and we wanted to bring cool images to everybody. And also, the web, we were getting email attachments that were from Hubble, and sometimes the descriptions were wrong. And how can you tell if you get email is right or wrong? So we thought that we wanted the developing web to be what we called a smart web, where you could go somewhere and you could see some of these popular images explained by someone who, I mean, we're not super knowledgeable about astronomy, but we're professional astronomers, so we have a better shot at it than some of these people who are just really not describing what was going on back in the 1990s. So here we provided a place you could go, and you could see images that were circulating as email attachments, and you could see them explained in 150 words or so, better than some of these emails that we're getting. So we wanted the web to be a smart web and not a stupid web. And so I think in some sense we were a bit successful in doing that. We gave people a place to go. But when we started doing this, we just wanted to do it. And it was actually many years before we actually applied to NASA for funding. And NASA was a little surprised. NASA's been very good. So let me not diss NASA. So NASA's been very good. They weren't quite sure what to make of APOD originally, but now they really get it, and they work with us, and they've been very good for us. And we're very happy to be part of NASA, to be brought to you from NASA, and to be part of science activation at NASA.
Thank you, Robert, and we hope that you'll get more support for the next years with APOD.
Thank you.
And we found out that, of course, you are also an academician. And the question here is, how do you find time to teach and do research and still maintain and publish APOD?
All right, good question. So one of the ideas of the science activation program of NASA is to take academics and pay for part of their time. So NASA gives me money that then I still teach at Michigan Tech, but I teach a lighter load. than other professors because NASA gives me money to pay for other people to teach the courses that I'm not teaching here at Michigan Tech. And so that time that I would have spent teaching then goes to presenting APOD in addition to the research that I do. So most professors teach. So I teach less now, a little bit less, and some of that time goes to creating the astronomy picture of the day. So that's how we do that. And I also have graduate students this way too. So so it's all part of the current setup, which works really well, in my opinion.
Thank you, Robert. And what are your future plans for APOD?
So APOD has looked pretty much the same over 28 years. Back in 1995, when we started, the center tag had not been developed. So APOD was left justified because there was no center tag. So we did, when the center tag came out, we centered it. So that's the way it is now. And it's looked pretty much the same. However, NASA is undergoing a web modification and modernization. And so we expect in the next couple of years that APOD will develop a more modern look and will look much the way of that many of the other NASA websites look. So currently we've kept our old look, but in the next couple of years, that's probably going to go away. And we're already in discussions for how that's going to be. So me, Jerry and I are both in our 60s. So I'm not planning on retiring anytime soon. Jerry, I don't think is planning on retiring, but NASA is asking us to have a plan for what happens when we do. We need a succession plan. So we are looking for successors now, and over the next couple of years, we were bringing on assistant editors, and we will be training people in what we do. And then hopefully, if things keep going, then at some point, I don't know how long we'll be going. So long as APOD keeps going, I'm going to go with it for the next several years at least, if I'm able to. And then eventually we will be handing it off to other editors. And in the best case scenario, Astronomy Picture Day will just continue on into the indefinite future, even if, I like to say that APOD is not just a web page, it's an idea. And the idea is that every day there should be an image that is discussed, or however you see it over social media, you see it over the web, you see it, and there's some image that astronomy is discussing a little bit more than other images so that it can be discussed. And so therefore it is of value in astronomy, in my opinion, that there be an astronomy picture today to focus interest on a specific image. And so we're lucky enough to be doing this in the beginning, and our hope is that this idea for the astronomy picture of the day keeps going into the indefinite future. Who knows what will happen, but that's the hope.
Thank you, Robert. More power to APOD, and hope it does continue forever.
Thank you.
And actually, I'm looking at the Q&A, and I think people are shy and they're not posting questions. But maybe we can ask now our panelists if they have questions for you. Imelda?
Hi, Robert. Yeah, Edwin here.
Yes,
I'm
hi.
just curious. Has any of the images that APOD had published, has that led to a discovery, further research, or technical papers by the
Yes,
professional
so
community?
yes, another really good question. Several APOD images. I can't call them up immediately, so I describe them with my hands. So one of the things that amateur astronomers can do is that they can do two things. Anyone can do this. You can, if you have a telescope set up, you can take some wide part of the sky and you can image it very, very deeply. Currently, both the Hubble Space Telescope and the James Webb Space Telescope see very small parts of the sky very deeply. But from the ground, you can see wider parts of the sky, and you have the time to do it. You don't have to request telescope time. And so people have imaged even famous nebula, and they see structures there that have never been seen before, because the ground-based telescopes and space-based telescopes don't see that wide an image that deep. Also, because of that, you can see there are images of galaxies that have features, particularly galaxies are typically are conglomerations of cannibalism, of colliding galaxies in the past, and they've left streams of stars. So many times these galaxies have not been looked at with professional telescopes and imaging as deep as you can with not only amateur telescopes, but amateurs can take already archived images from Webb and Hubble and now Euclid and really use modern techniques and bring out very faint features. And so we're being able to see features that show the histories of the tumultuous histories of some nearby galaxies that have never been seen before. And this is, some people have noticed, some professionals have noticed that, oh, here's a picture on APOD. Oh, I know that image, but I don't know that feature. And so they get into conversations with either the astrophotographer or the people who did the data processing, the image processing of the image, and then out comes scientific discovery. There have been dim nebulas that have been discovered. Things about comets have been discovered. Things about galaxies have been discovered. Things about just the background nebula you see in the sky have been discovered, and they've been seen by professionals first on APOD. But APOD isn't unique in that. There are many people taking deep images, and there are other sites that show deep imagery. So APOD is not unique in this sense, but APOD has been fortunate enough to feature several images from which discoveries have been made.
That's great to hear, Robert, that APOD is able to contribute to pro-am collaboration.
Yes.
Robert, I really want to thank you and your colleague for what you do, because it to some people, they think it's just about choosing a photo, but now with your talk, you see what goes into an astronomy picture of a day. It just reminds me of when I was doing something similar to what you're doing as a photo editor, choosing images for a gallery and all that for the magazine. To me, my guy there was I needed a photo to inspire and to educate. It's not just a beautiful picture, but it's something that would get a kid to be interested in astrophotography, or a kid to be interested in astronomy in general. And I think through the years and into the future, you will inspire future astronomers and future scientists who will make significant discoveries just because they get inspired by the photos they see in APOD. And I am, to some people, like, why would you have a periodic table of elements? But if you really look into the caption and see why that is, Edwin and I were just like, we love this, we love this very much, because that's where you see where the elements came from,
I noticed that both Edwin and Imelda, both of you have inspired people as well. So I'm admiring you as well. But thank you for your kind words.
Yeah. Thanks, Robert. Jet, if you don't mind, I just have one follow-up question for Robert.
Okay.
Robert, as far as you know, is APOD the only website of its kind in the world? Are there anything similar to it in other countries or in Europe?
Well, many places have like Astronomy Magazine has a picture of the day. Space.com has a picture. There's Space Weather has a lot of pictures. Sky and Telescope. A lot of places. There are Facebook groups that do something a little bit similar. But to my knowledge, I think we were the first. And currently, we're among, if not the most popular, and we are fortunate enough to carry the NASA brand. So NASA itself has a lot of credibility, and so Jerry and I are professional astronomers, so we we select things. We sort of just like you two, Edwin and Mata, we've been around astronomy for a while, so we know what's really a little bit more important than someone who's just arrived at astronomy. So we're able to have a bit of using our experience to pick out what's really important. So that goes into our selection process. But there are things that do pop up. You can submit your images to any number of sites. There's also Earth Science Picture of the Day that's run through the University Space Research Association. And there are other Pictures of the Day sites that are not in astronomy. So there are some things that are out there that have similarities to APOD that I know about.
I think what we personally like about APOD is the fact that not only are the images well curated, but also the caption that goes with it is so informative and so instructive that it really makes a difference, because it explains, what you're seeing, and in such a way that it's accessible to everybody.
And the science behind the photo.
Yeah.
Yeah.
So thank you for doing this.
Yeah, I agree. What makes APOD a hit for us? The caption.
Thank you. Yeah, so we tried. We were both professional astronomers, and we now have 28 years experience trying to write captions that we're better than we used to be. Here's a interesting thing for you. About half the images now have a comic relief link, many times to a cat or a dog with an unusual expression. And the idea with those links, many of the links are just to describe in more detail in the web that we can't do in our 150, 160 word caption. But one of them is supposed to be a little bit funny. So many times we get email that people notice that if you you hover over some of the links, you might find a picture of a cat doing something funny that's relevant to the word that it was linked to.
Right.
So that's just something that we do. So people might look for that just to be fun.
Yeah. So I'm pretty sure Jet is already, his ideas on how to capture the next solar eclipse so he can send it over to APOD, right, Jet?
Yeah, thank you. I have another question, maybe for Robert. Robert, you discussed the use of AI, not only for streaming. It's similar to, I think, to when we write scientific papers, plagiarism.com. Is that something similar, that when you screen the images, you use AI? And what do you think will be the future of AI for processing and for astro imaging?
Well, we don't use AI to screen the images.
Okay,
So
thank you.
this is all, we're just, maybe in the future it will be, I don't know, but currently Jerry and I don't think Jerry's AI. I sometimes joke that my intelligence might be artificial, but I'm not officially AI. So we're just doing it the old-fashioned way. We don't have any AI that does that. However, once though, for laughs, we had a caption that was generated in a very specific way. It was generated with AI, but we clearly identified it that. But besides that, we just write our captions, and we make, you can sort of tell because occasionally, well, we have awkward wording sometimes, although we have some experience, but we're not. But AI is affecting astronomy in many ways, because now when amateurs and even professionals take images, it makes it easier to take it. Images aren't what you think they are. When you take a deep image of the Andromeda Galaxy, there's like satellites going through it. There's planes that go by. There are stuck pixels. And when you see the image of the galaxy, you don't see any of that because it's taken out. It's taken out by hand. First of all, it used to be very difficult before there was any kind of digital processing to take it out. But it was still hard to do, but it was doable. Then with as digital manipulation became more advanced, then you could do it. But now there's essentially artificial intelligence engines that will take it out. And you can just say, remove that satellite trail, and poof, it's gone. And so it's making deep astrophotography easier for most people and makes more things easier. And another thing we saw is it can make videos. So you take a few shots and you feed it into an artificial intelligence engine, and poof, you now have a video. Also, you can now imagine what it's like to be certain places that you can't actually go. You give it all the information that you know about something, and you ask it to generate images. And then you take your knowledge of what it is like, it might likely be like in that location, and weed out the bad ones and say, here, this isn't a bad one. And I think that's inspiring to people, because they can see, oh, this is an exoplanet, and it looks slightly red in front of its background star. But that's not as visually exciting as picturing yourself to be on the surface of that planet. And thanks to AI, we're getting better and better at making those visualizations.
Thank you, Robert, for the answer. Any other questions from the panelists?
Yeah. Hi, I have one.
Peter,
Hi,
yeah,
Robert.
Peter, please.
Yeah. Before I give my question, I'd like to congratulate you once again for those outstanding images. They're very inspiring, and I was trying to picture in my mind how to be able to acquire such fantastic images using smartphone astrophotography. So, in relation to what Imelda said earlier, um, have you featured images taken by means of smartphones afocal to telescopes? Because I always do smartphone astro imaging to inspire astrophotographers who are also into this kind of method. Perhaps also trying to open doors to kids who love to take images of the heavens.
Yeah, smartphones are great. So I don't think we've done too many of those, but I think we've done a couple smartphone images, but I don't recall which one specifically offhand. But what smartphones can do for people is they can put people at the right place at the right time. See, if you have a fancy telescope, or you're at a major telescope, you are at a specific place and you only have a certain amount of time. But there's so many people with smartphones now that you can see eclipses from different angles. You can see meteor showers from different places. You can see unusual astronomical events, launches of satellites. So smartphones allow everybody to be around, and everybody to the ability to take astronomical imagery. And with that comes a better chance of being at the right place at the right time. And so we do see some images of the right place at the right time that are sent to us. And I think we've been able to run a couple of them. I'm sorry, I can't tell you specifically which ones they are. But smartphone imagery, I think, is, you can just take your smartphone, you can put it up to your telescope too. That's another thing you can do. Smartphones are so good, you can do that now. I'm going to refer to an old project of mine. So way back 20 years ago, I was interested in trying to create a complete image of the night sky. So we're creating something we called continuous cameras. And these continuous cameras were fisheye images that would see the entire sky. And this entire sky, so we had our continuous cameras at every major observatory in the world, on Mauna Kea, in South Africa, in Australia, all over the world, Canary Islands, Arizona, and Hawaii. And we had all of these reporting back at the same time. So we were able, because of such wide angles, we could see essentially the whole sky. And therefore, if any star was to do anything unusual, we would know about it. But we were able to get variability of stars, and we were able to get actually parallax of many meteors. If your meteor is seen and you can see it from two different locations, then you can get where that streak was from, and you can map it. You can actually get a three-dimensional information on where that streak was, so you can know where it came from. You might be able to find out what asteroid or comet it came from. So now I think you can actually do that with smartphones. So all you need, then we needed pretty sophisticated CCDs, we needed an expensive fisheye lens, but you can get a $20 fisheye lens that can be strapped onto a smartphone, but you don't even need that. You just need lots of people who put their smartphones out on the sky, and you can get essentially an image of a large part of the sky at any time from all the way around the globe. And so every star is variable at some level, and meteors are always coming in, not just during meteor showers. And so I think smartphones, hopefully in the future, will be able to get us to track the complete night sky, whereas that was really not available before that. Our CONCAN project, we worked for a couple of years. We were never able to get the complete night sky. We got most of the night sky, but now many of those cameras aren't working. And although there are fisheye lenses working around the globe, they're not working together, but the smartphone can do that. So that might be a small area of what smartphones can do, but I think that's one area where smartphones can contribute to research astronomy. Sorry for the long
Thank
answer.
you. Yeah, thank you, Robert. I know that there were quite a few instances that APOD liked my astro images that were taken by a smartphone. I think these were from my postings in either Instagram or Twitter. So thank you,
Okay.
sir. Thank you very much for those.
Thank you.
Robert, I just want to add to something when you said right place at the right time. I regretted it the other night. I was outside in the backyard. You know, Edwin was unloading the car, and I heard an owl hooting. So I brought out my phone, and I turned on Merlin, which is an app, and it picks up the sound and identifies what kind of owl. And it was a
I have
great
that.
owl. So I couldn't see it, of course. I could hear it. I know where it was coming from. So I put out the phone, took a picture, and it was a silhouette of the tree with the owl in it and some stars. And then as soon as the exposure was done, there goes the Gemini.
Oh, wow.
It would have been
Missed it.
in the frame if it was still taking an exposure. That's right place at the right time.
Yeah.
Could have been.
I have that app, so I use that app myself.
Oh
So-
yeah, it's very good.
So what
And so
happens is in the morning, sometimes when I wake up, I hear these bird calls and I don't really know some of them I know what they are, but some of them I don't know what they are. So now I turn on my Merlin app and it tells me what bird that is,
Yeah,
even though I
yeah,
can't see it at all. But so
yeah.
cool.
So I was able to, take a picture of the owl that night using my smartphone and some background stars, but missed the
missed.
Gemini.
Thank you. That's a bonus info for our birders in the audience.
Yeah.
Any other questions? Well, if
Yeah.
none, thank you so much. Yeah, you have, Edwin?
Yeah, just ask. I'm just going to ask Robert. Sorry, just a brief summary of your latest book. What is it all about? And it's available through Amazon, I think, right?
Yes. Okay, so this is not, so I'm now not representing NASA at all. So this is just me. So yeah, so I'm a physics professor and I've been interested in so things that can go, so humans and things with mass can't go faster than light. But some of my research involves things that actually can go faster than light, but it's counterintuitive. So let's say you had two lights, right, that blink one after the other. Let's say they're like Christmas lights. You ever watch Christmas lights and you see them blink in sequence and you say, wow, it seems like the blink is jumping from one place to another. But you can attribute a speed to that, but there's nothing really moving there. So if the two lights blink at the same time, you can say that the blink went from one to the other infinitely fast. But you can have one blink just after the other. And then the blink actually can seem to move from one light to the other faster than light, even though nothing is really moving faster than light. So there are things like that, like shadows are actually very similar to that. Shadows aren't really anything moving, it's just the absence of light. And actually shadows, it turns out, can move faster than light. There are other things that people don't realize can. And for instance, your laser pointer, when you take a laser pointer and put it on the wall, there are different laser spots that hit. Different photons hit. Those photons aren't related. There's nothing that's moving faster than light, but it looks to you, and not only looks to you, but that spot moves across the wall faster than light. And so this creates some really interesting things that you can analyze. And that, so the book is written on a popular level, and it talks about how it is things can appear to move faster than light, even though it's completely consistent with Einstein's special relativity, and nothing with mass is going faster than light. But it can even look, because things appear to move faster than light, they can even appear to move backwards sometimes. And so that has actually, well, so that's actually part of my research, because you can get shadows that move in astronomy faster than light. It's a well-known phenomenon, but we're trying to find it in an astronomical context, because then it would actually tell us something about what's going on out there. It wouldn't violate any part of special relativity at all, but it could tell us more about what's being blocked where and where the shadows are going and things like that. So we're working for that. And so I break down, I review the basic things of what it is about, why the speed of light is a limit, and then I review why blinking lights can appear to go faster and why shadows can go faster than light. And it's all a bunch of puzzles, and it's all for someone who just has an interest in science, who enjoyed astronomy and physics in high school, and they're just curious about these kinds of things. And it's written on that level, and it is available through Amazon. And thank you so much for mentioning that. I just completed it this past year. I've been working on it for many years, actually, for more than 5 years, I'd say. And finally, it's come out. And so it's gotten some positive reviews, and so I'm grateful for that. So thank you for mentioning it.
So congratulations, Bob, on your Robert, on your latest book. And so they could just search your name at Amazon.com, right?
Yes.
Okay, great. Thank you.
Thank you. We'll
Thank
look
you
it up.
so much
Thank you.
again
Congratulations.
for doing this, and I'm pretty sure, you know, you will be inspiring more people and the future generation.
I hope so. It's really something that's amazing that Jerry and I have created something that can inspire some people. So we're so happy that we're able to do. We've stumbled into doing something that allows us to do that, as you have. But we're lucky enough to do that as well. So thank you so much for your kind words, and for allowing me this opportunity to speak to the Astronomical Society of the Philippines, League of the Philippines. So I'm very grateful.
Thank you.
Thank you.
Okay, so if there are no more questions, thank you so much we've taken so much of your time already, Robert. So we would like to show our appreciation with this certificate from the Astronomical League of the Philippines. And if you would allow me to read it, this certificate is presented to Dr. Robert J. Nemiroff for his invaluable insights, experiences, and expertise shared with the participants of the online talk entitled NASA's Best Space Images for 2023, held as part of the ALP Astronomy Expert Speaker Series, given the 7th day of December 2023, signed by Mr. James Keventy, President, and yours truly, Dr. Jose Francisco Aguilar, Vice President. And before we let you go, Wally, before we let you go, Robert, may we have a group picture, Robert, with you? I'll just stop sharing. James?
You're on mute, James.
You're muted, James.
Sorry. A little closer, Imelda and Edwin.
Closer together.
Okay, 1, 2, 3. One more. 1, 2. Thank you.
Thank you. Nice picture.
Thank you, guys. Thank you so very
Thank you, Dr.
you,
Nemiroff,
everybody.
for joining our webinar. Really highly appreciate it.
Thanks again for the certificate of appreciation. This has been great. I really appreciate this. Thank you.
By the way, Merry Christmas. Advance Merry Christmas and Happy New Year.
Merry Christmas.
Yeah, Robert.
Yeah, Merry Christmas.
That way I
everybody.
forget it.
More power to APOD.
Yes.
Yes, more power to
Yes,
APOD.
more power to APOD.
And you have one more announcement.
And
Chat.
Robert, hopefully in the future, if you have something that you know you'd like to share with us, you can come back and give a talk on maybe that faster than speed of light.
Okay, so yeah, let's talk about that in the future. So thank you very much.
Yeah.
Thank you, Robert. Before we conclude today's webinar, I would like to thank all our attendees for joining us. We will be sending you certificates of attendance by email, and for those who were able to join us today. And as mentioned earlier by James, this is the 21st webinar in our ALP Astronomy Expert Speaker Series since we started last year. So we've completed 2 years for this astronomic expert.
I think it's 3.
Yeah, 3 years. Yeah. And our first speaker was the late Dr. J. Pasakov on April 23, 2022. Our other esteemed speakers since then were Mr. Rolt Live, Mr. Joe Reo, Mr. Fred Espenap, Mr. Robert Reeves, Mr. Ken Crawford, Mr. Dave Eicher, Professor Matthew Barlow, Mr. Scott Roberts, Father Christopher Corbally, Mr. David Levy, Mr. J. Kelly Beatty, Imelda Gilson and Edwin Aguirre, Dr. Daniel Green, Dr. Heidel B. Hamel, Dr. Deborah Emma Green, Brother Robert McKay, Brother Guy Consolmania, Hilary Andales, Dr. Valentin Pilet, and of course today, and Dr. Wadi Pacholka, and for today, of course, Dr. Robert Nemiroff. And hopefully we will be continuing with this in 2024. And again, we are so grateful to all our webinar speakers who very generously gave their precious time to share with us their knowledge and expertise to the world amateur astronomical community. And of course, we can never thank you enough. And for those who missed all our previous ALP Astronomy Expert Speaker Series talks, you can view them at your own leisure from our official ALP YouTube channel shown here. And we upload all our videos there for you. And for our next speakers, hopefully for next year, we have Dr. Mike Brown, a planetary scientist at Caltech, and Dr. Meg Urey, an astrophysicist at the University of Yale University and an expert on extragalactic astronomy. Please wait for further announcement regarding these upcoming talks in our at AstroLeague's website, astroleaguesfields.org, and at our ALP Facebook page. We will be making the announcement soon. So thank you again, everyone, and clear skies, and Merry Christmas.
Merry
Thanks,
Christmas.
Jeff.
Bye. Thank you.
Bye-bye.
Thank
Bye.
you.
Bye.
Robert.
Thank you.
Thank you, Doctor.
Thanks,
Take
Take
Robert.
care.